Nomenclature of cycloalkanes. In naming cycloalkane, it's almost the same as naming the alkane straight chain. In the middle, you have the parent. At the end, suffix what family. In cycloalkane, your suffix is A and E, ane, and prefix at the front, where the position of the substituent, prefix, or how many substituent, it's a prefix you have here, and before the parent you add the word cyclo. Cyclo means a ring is present in that alkane. For example, the suffix A and E, ane, group alkane, and then hex means 6 carbon parent, and add the word cyclo before the parent, prefix the substituent at carbon number 1 and carbon number 2, there are 2 methyl, so 1,2-dimethyl for prefix. The parent hexane at the word cyclo at the front. Parent name. If the number of carbon atoms in ring is equal to or greater than the number in the substituent, the compound is named as cycloalkane. Means the parent is cycloalkane, not the straight chain. For example here, 3 carbon cycloalkane, 3 carbon alkane straight chain, no cyclic ring. So the parent will be cycloalkane if you compare the total number of carbons are the same, or in cycloalkane is greater, means the cycloalkane will be the parent. So the name of this compound is propyl cyclopropane. The parent is cyclopropane, parent name at the back, and then the straight chain will become the substituent, propyl cyclopropane. You don't have to put number 1 because this is the parent. This substituent is at carbon number 1. You don't have to put number 1 here because if you change the position of the substituent, change it to here, this carbon will become number 1. If you change the position of the substituent here, the carbon will become carbon number 1 as well. It means when you change the position of the substituent, the number doesn't change. You don't have to put the number in front of the substituent. So it's just propyl cyclopropane. If the number of carbon atom in straight chain is greater than the number in the ring, the parent is straight chain. So here if you compare the parent, 4 carbons in total, 3 carbon in cyclic, 4 carbon in the straight chain. So the higher number of carbon will become the parent. So the name of the parent here is butane and the substituent is cyclopropyl. So here you put number 1 cyclopropyl because this position of the substituent, the cyclopropyl, if you change the position of the cyclopropyl at this carbon, it will become 2 cyclopropyl. So that's why you have to put the number in front of the substituent. When the straight carbon chain compound contains functional group, even the straight carbon chain compound has less number of carbon than in the ring, if that straight chain contains functional group, the cyclic portion becomes alkyl substituent, means the cyclic will become substituent. For example, this compound, 1, 2, 3 straight chain carbon only, and then compare with 5 carbon in cycloalkane. So between these two, the straight chain carbon will become the parent because it has functional group. It has functional group. The cyclic will become the substituent. So we choose the parent which has the functional group will become the parent. So here at carbon number 1, carbon number 2, carbon number 3. So at carbon number 1, 1 double bond. At carbon number 3, cyclopentyl substituent. Cyclo is considered part of alkyl group name for alphabetizing purpose. For example, when you have the parent cyclohexane and then substituent for this compound is cyclopropyl and dimethyl, methyl cyclopropyl. So when we need to arrange in alphabetical order, this methyl, look at M, not di, M, and then cyclopropyl, we consider the C. Cyclo is considered part of alkyl group name. So C first and then M. So that's why the name is 3-cyclopropyl 1,1-dimethyl cyclohexane. If only one substituent is present, here no number is needed. So the parent is cyclopentane and only one substituent, because only one bond is attached to the parent, so one substituent only. The substituent is sec-butyl. Sec-butyl is 1 methane at carbon number 1 branch. That is sec. So the name of this compound is sec-butyl cyclopentane. When two same substituents are present, number the ring so that the second substituent has low number is possible. Same as in a straight chain, choose the low number for substituent and then number the ring by alphabetical priority. So here, carbon 1, carbon 2, carbon 3. If you count clockwise, 1, 2, 3. If you count the number of carbon anti-clockwise, there's carbon number 1, number 2, number 3, number 4, number 5. We prefer 1, 3 compared to 1, 5. It has greater number 1, 5. We prefer low number, so this carbon has to be carbon number 1, carbon number 2, carbon number 3. And then number the ring by alphabetical priority. So here methyl and here ethyl, so you number 1 at this carbon, because carbon 1, carbon 2, carbon 3. Substituent will get number 1 and 3. If you put number 1 here at methyl, 1, 2, 3. The substituent is also 1, 3. So which one is 1, which one is 3? Because if you number from here 1 and 3, here 1 and 3, so which one do we choose? Choose number 1 at the alphabetical order, so according to the alphabetical priority. So number 1 will be at ethyl, because ethyl, E first and then M. 1 ethyl, 3 methyl cyclohexane. When 3 and more substituents are present, begin at the substituent that leads to the lowest set of location numbers. So lowest set of location number 1, 2, 3, 4. We prefer 1, 2, 3, 4. And then if we put here number 1, number 2, number 3, number 4, 5, 6, you'll get 1, 4, 6. We do not prefer grade number 1, 4, 6. We prefer 1, 2, 4. Okay, so lowest set of location numbers. And then arrange naming of substituent according to the alphabetical order. E first, and then M, and then P. 4 ethyl, 2 methyl, 1 propyl cyclohexane.